In this video, I'm going to give a quick demonstration of the select by location and subsequent data analysis for roads of Yates County. First thing we need is some data sets, and those will be downloaded in the usual fashion from Blackboard. I've already downloaded and unpacked them, so I just need to ask for add data. I can add the towns of Yates County, and I can also add the roads of Yates County. As such, becomes hard to see the boundaries and the extent of each of the towns now. So I am going to symbolize with red borders and triple thickness. And now we can see there are 8, 9 towns in Yates, and each of them has their own road network. And the question, the goal for this analysis is to figure out how many road segments and how many meters of road are in any particular town. Well, the distinguishing factor of these roads is that they're geographically located inside their town. So we're going to use select by location to do that. Before I go into select location, since the exercise is a town by town exercise, I'm going to specify or identify the town of interest right off the bat by asking for clicking and getting the town of Jerusalem selected. There's the town of Jerusalem, a distinctive shape, and the cyan boundary indicates that it's selected. I can clear the selected features. I could have also gone into the attribute table and identified the town of Jerusalem and selected it by hand or from the table like that with the same result. Now the select by location is found under selection, select by location, and it's a dialog box. I have several choices to make. The features that I want to select are roads, and right now the data set includes all the roads of the entire county. I'm going to make a subset of roads, select features from roads, and I'm going to use as a source layer, which is a poor name. It's really the geography that I'm using to make the selection, and that's going to be the map of the towns, but the one selected feature in particular, which is Jerusalem, and I'll use intersect, and I will end up with roads that cross the border, but that's fine for this exercise. There's a lot of other choices actually in hand, but we'll go with a simple, straightforward one, and I just need to say OK, and now all the road segments located within, selected by location within the town of Jerusalem are shown, and we can actually open the attribute table and see that there's 1,012 segments that are selected. If I want to show only those segments, I can click on this little box here, and only the selected segments are being displayed now. And then way over at the far side of the data set, I see shape length, and you might recall that when there's a subset selected, 1,012 segments are selected, I can right-click, ask for statistics, and it will tell me that the sum of all of the lengths of the 1,012 selected road segments, which we know are selected because they're in the town of Jerusalem, that's what we did, has a total length of 322,661. That's the total length. I could go a little further even and go ahead, and this is an add-on. This is a kind of a bonus. I could say select by attributes, and I could do something really fancy. I could say select from the current selection, so I can subset the subset, and I could go ahead and ask for CFCs if I can find them, the code, FCC, the code equal, get unique value, A31, and I can say OK. And now what's selected is the town boundary. Don't be confused by that. Plus the road that is both inside of the town of Jerusalem and has an attribute of A31. So I can now open up the roads data set and see that now there's only 86 road segments left, and there's State Route 54A, Westlake Road, which are actually the same thing. I know Penn area, sort of, and State Route 54 and Westlake Road are kind of the same thing. And I have no idea why Maple and Elm count, but they do have the A31 code, and I could go ahead and right-click, ask for statistics, and there's the total of there's the total length of roads that are A31 as an attribute and located within the town of Jerusalem. So that's a pretty potent analysis for the 6 minutes that this took, and that's enough for this video, and I will end it as soon as I can get back. Well, I'd really like to end it. There it is.